Hello everyone, welcome back to my channel. So today I've come up with a very solid topic, that is piston engines, and it is important because as you know, to become a pilot we fly trainee aircrafts like Cessnas, Pipers, and all of these work on an engine named as piston engine. Before flying aircraft with jet engines, we fly aircraft with piston engines before. So before starting, I just want you to give some tips on how to take these chapters and move ahead, because these are few important topics which you need to know throughout your aviation journey in order to also crack your interviews and all of it, because in interviews they can ask you how a piston engine works. So before starting this topic, I just want you to have a grasp of all the topics, and in order to have it you need to make a proper note, and you guys can make notes at the same time while watching the video. You can stop the video and write down the notes, and also replay it as many times as you want in order to understand. I'll try my best to make you guys understand, and you can also drop down your questions if you have, and I'll try my best to answer all of it. And without any further ado, let's get started. So as you can see, the topic is piston engine. So piston engine is internal combustion engine. So before getting into, okay, so it is a ICE, that is internal combustion engine. So what a internal combustion engine means? So internal combustion means how the combustion is taking place inside the engine, and we see combustion of fuel and air mixture. So before this internal combustion engine, there were also external combustion engine. So if you think of external combustion engine, what could it be? So example is a steam engine. So steam engine works with the principle of external combustion engine. So I just want to give you a very rough idea of how steam engine works, but it is not important for the DGCA exam and all, but just giving a rough idea about the engines. So external engine is so it is like there is a pot, kind of a hot place where you put your coals and koilas and all of that, and it is heated, and above it is a water tank, kind of a boiler. So as the metal tank is heated, which has water, when we heat a water, what happens? Evaporation occurs, and that is the byproduct of it is steam. So steam is passed through a streamlined flow, you can see, to the piston engine. So I can show you a video on how it works. So I've seen, search on YouTube video, so you guys can see how the cola is put in it, coal, and this is the water tank, and the heat steam engine is produced. Okay, you don't have to go so deep in it, but yeah, this is what external engine is. External engine works like. Okay, so we'll just read all the lines so we don't miss out on any. So internal combustion engine, it takes place inside the engine. Fuel and air mixture, as you know, there combustion of fuel and air, we'll look on it thoroughly in later page. Okay, if combustion engine is outside, it is termed as external combustion. Clear? Example, steam engine. Example like railway, how it works. So there is a like a coal, you put coal and it is heated, and this water which is boiled is heated, and this steams goes in it is for the work. So to propel the engine, they used to heat the water. Okay, and to propel the engine, like to make this engine. So I'll tell you what this is. So this is like a piston, it is like a syringe, and this is a cylinder. So how like this is my cylinder and this is a piston, so it used to go like that. Okay, so my suppose if I get a steam of air, and it is of high pressure, and as it is, you know, pushed with the pressure, it starts working, and that is how it moves the wheel and moves the engine. So it moves the engine and then moves the wheel. Okay, and the steam has applies pressure, and this is ECE, that is external combustion, and this piston engine is a reciprocating engine. Okay, so before starting all of it, I just want to show you a video on how piston engine works, so you get an idea of what we're actually studying, because it's quite difficult to just show on the paper with the drawings how it is. So I'll just show you a video. Okay, so this is a very perfect video, so I'll just start.
Reciprocating engines have several cylinders.
So
Inside of those cylinders, fuel and air are mixed, compressed, and then ignited.
This is
As
cylinder.
this fuel-air mixture is ignited, its explosive force moves the piston inward. These pistons are connected to a crankshaft.
Okay, that is the later topic. So you see how this is the cylinder and piston engine moves. So it is a reciprocating engine. This is also an important point. So reciprocating engine is a movement of back and forth, like it is moving up and down, and that is how we say it is a back and forth movement. Okay, so just for your understanding, I'm using such terms, but reciprocating back and forth is the right term, not up and down. Okay. Now, see this piston engine moves back and forth inside the engine. So as you saw, these are the cylinders. Each piston has a cylinder. So there are 4 cylinders, 4 pistons in a normal Cessna. And this piston engine is connected with a rod. So this is a rod that goes up and down, and this is the rod called as connecting rod, which is connected to a crankshaft. So this is a crankshaft, these are the connecting rods. So this rotates, so as it rotates, it goes like that. Okay, and this is a linear motion, this is a rotatory motion. So this rotatory motion is caused by the crankshaft, which turns the propeller. Okay, this is a very good video. We should watch it. Okay, see how this is a crankshaft rotating, propeller is attached to here, and how the piston engine is moving. Okay, you see these are the 2 valves. Okay, so 4 strokes are there. Okay, we'll see this. So there are 4 strokes in a piston engine. First is intake, another is compression, the 4th is power and thrust. So we'll come this on later chapter. First we study what are the, you know, parts of a piston engine. So the cover, so this is the engine, piston engine, and it covers with a cylinder. So this is the cylinder, and cylinder has 2 valves, the inlet valve and the exhaust valve, and it opens and closes depending upon what stroke it is. Okay, so this is, and this is a spark plug. Fine, so these are the parts in it. Now let's see the 4-stroke. Now I guess I've covered all the part. Let's just read before getting to another part. The piston is connected to a crankshaft. The piston, this is a piston that is connected to a crankshaft with a connecting rod. Okay, now whatever you attach to the crankshaft, whatever we attach to the crankshaft sorry guys, I'm just having a bad throat. So sorry. Okay, now whatever you attach to the crankshaft, it will also rotate. So you you attach the crankshaft, it will rotate as it is as the propeller is attached, it will rotate to produce thrust. Okay, so the propeller is attached to the crankshaft which rotates. So this is the linear motion which is converted to the rotatory motion with the help of crankshaft. Okay, now moving, the maximum limit of a crank, or the maximum limit of a piston is the top dead and center and bottom dead center. So as I said, it goes up and down, up and down. So the up it can go is top dead center, and the bottom it can go is the bottom dead center. So this is the limit it can, you know, go to, the maximum. Okay, now moving on to the next. There is the exhaust valve. So the exhaust valve, where the exhaust gases are going out, so that is exhaust valve, and intake valve is where the fuel and air mixture comes in from. Okay, from TDC to BDC, this from this top dead center to bottom dead center, this is called as one stroke. Okay, now studying the strokes, how it works. Now see this video, very nice video. Okay, you see how this is happening, how this is going. An inlet valve goes down and comes up. We'll see it again. It goes down and it comes up, goes down and comes up. This piston goes down, and this inlet valve, from where the fuel and air mixture is going. Okay, as things are going inside, it will. Okay, so from the starting I'll say, so first it was at top dead center. As it goes to the bottom dead center, this creates a suction effect. As like suppose if I take an example of a syringe, and if I, you know, put a syringe on my skin and I try to pull it out, so a suction will be created inside the bottle of the syringe that pulls things from, like it will take out blood from my skin, right? And that is how things are happening here. A suction effect is created that pulls the fuel and air ratio mixture. Okay, through inlet valve. First topic, let's read the first stroke. When the piston moves from top dead center to bottom dead center, a suction is created, and that draws the fuel and air mixture. And got it? As the piston engine goes down, this draws the fuel and air mixture. Inlet valve opens, fuel and air, this is F plus A, fuel and air goes inside, goes from top dead center to bottom dead center, which creates a suction effect and draws fuel and air mixture. Okay, I've written it again, but okay, these are the points. Got it? This first process is called as induction. Now moving on to the second. Okay, this is the second. You can see what first happens. As in the first, it was from top dead center to bottom dead center. Now in second stroke, it is called as a compression stroke. You can see how things are getting compressed. So from bottom dead center to top dead center, the fuel and air mixture is compressed, you know. Okay, now let's read. The piston moves from BDC to TDC. Both valves are closed this time. Okay, both valves are closed, so the fuel and air mixture cannot escape, and air gets trapped and compressed as the piston moves up, and that compresses the fuel and air mixture. Okay, so you think this is the fuel and air mixture, it is compressed highly, so the pressure and temperature will rise rapidly. It will rise, it will become hot like hell. And as this happens, there's a spark plug. I just taught you right here, spark plug is there. So after in compression, there is spark plug that generates a spark, and as it generates a spark, with that pressure, the fuel and air, as it generates spark, the fuel and air mixture is combusted, like it is, you know, it gets boom and it goes down like hell. Okay, If compression pressure, okay, in compression pressure will rise and temperature will also rise. Here is a moment. It gives spark by spark plug. Okay, the spark is getting by spark plug, and the fuel and air mixture will be combusted by the spark. So there are two things that people can ask you. That is, what is the difference in combustion and explosion? Because why it's not getting exploded, but why it's getting combusted? Okay, so in this case, the fuel and air mixture is it is combusted on layer wise, like it is a controlled combustion, I would say. So what happens is, okay, we'll just read it. Explosion means sudden, there is a sudden burst of fuel and air mixture. But what happens that in a piston engine there is a controlled combustion, means the moment the spark plug is leaving the spark outside, the fuel and air mixture which was compressed, the fuel and air mixture which was compressed, it will burn layer wise. Instead of blast, it is a pure pressure on the cylinder, so it will burn layer wise, and it creates so much pressure on the head of the cylinder that it goes down. Okay, in piston engine it will burn layers by, it will burn layer by layer, fuel by air, okay, fuel plus air ratio, it will burn layer by layer, and exert pressure on the piston head, and combustion is so powerful that it goes down, and that makes the third cycle. Okay, we'll get back to the video again. See how it's going up, and both the valves are closed from top dead center, bottom dead center to top dead center, and okay, spark plug is generated which pushes the piston downward, and that rotates the crankshaft. So as it goes down, the crankshaft is rotated. Okay, the power stroke is the only useful stroke that causes the crankshaft to rotate, because it rotates the propeller. Make this point, note this point. Okay, so in power stroke we have two rotation of crankshaft, the most powerful stroke. Okay, and as it goes down with the strong pressure that is given, again bottom dead center it is, and then at the fourth last point you can see lot of burnt gases, and hot gases are left behind of fuel and air mixture, and this goes out when again the stroke moves from bottom dead center to top dead center, getting the exhaust out from the exhaust valve. Okay, so this is the topic. Okay, we'll watch this video and understand it. You'll get a clear, whatever I've taught, you will just clear all your doubts, and it will clear everything.
Work. It runs in 4 phases: intake, compression, power, and exhaust. First, strokes. The intake valve opens and a fuel-air mix enters the cylinder.
Okay.
Then both valves close and the piston compresses the mix. A spark ignites it, creating pressure that pushes the piston down.
Bottom dead center.
That's the power stroke. Finally, the exhaust valve opens and the burnt gases exit the cylinder. Timing is key. Valves often open or close slightly before or after each stroke to improve efficiency.
Connecting rod piston.
When both valves are briefly open,
now we'll just take overview of what we have studied and also a few points added for exam. So this is a very important PDF, so I'll just read out for you. We'll read it together. Okay, so introduction. The piston engine works on a theoretical Otto cycle. So Otto cycle, Otto, it is kept on a person's name. Otto cycle, like how Bernoulli's theorem is placed, it is named on a person who invented it. So that is why Otto cycle, Otto was a person. So that is why it is named as Otto cycle. And jet engine, how jet engine is named as Brayton cycle, so it is named on a person. So Otto cycle, that is why it is called as Otto cycle. Okay, a stroke is defined as a linear distance between a piston moves in the cylinder. So linear distance, how piston moves in the cylinder, so that is a stroke. So you see here, stroke is the top dead center and the bottom dead center, that is stroke, you see. Okay, now moving on to the next. When the piston is at the top of the stroke, it is said to be at top dead center, and it is at the bottom, it is said to be as bottom dead center. Okay, now the piston is connected to a crankshaft. So as I said, this piston is connected to a crankshaft by a connecting rod. Okay, so it is connected to a crankshaft, and as the piston moves from top dead center to bottom dead center, it rotates at 180 degree. So there are 4 strokes. So 4 strokes will cover how many degrees? Tell me, guys. Okay, so this is 720 degree. A stroke is equal to twice of crank throw. A stroke is equal to a stroke is what? Top dead center. Stroke is a linear distance between top dead center and bottom dead center. So stroke is equal to twice of crank throw. So one stroke is equal to twice of crank throw. Now these are few this is the labeling of the piston. We will see these are the valves, this is the spark plug, and the cylinder, the piston, the connecting rod, the crankshaft. We'll study crankcase, crank pin and all of that later, but you can also go through the labeling of what is it. So these were the engines that were used. So this is a horizontally opposed engine that is used in the Cessnas, and otherwise, so how do I show you? Okay, let me just, yeah, you can see all the engines. Okay, now the operation of theoretical Otto cycle. There are 4 strokes: induction, compression, power and exhaust. So we'll see the piston moves down, volume increases, pressure reduces. Volume is getting increased, you can see the volume is increased. The pressure reduces because there is low pressure. Okay, wait, low pressure, yeah, there is low pressure inside, high pressure outside. So how it moves, high to low, so air and fuel will go inside. Now the next is the piston rises as it goes up. No, my bad. Okay, this is the second. It was down, bottom, now it will go up. So the mixture is, yeah, I was right. Yeah, this point now. Yeah, so the piston rises, volume is reduced, pressure is increased, both valves are closed. As I said, this is the compression. It will get compressor fuel and air. Now the third point, power. So the mixture is ignited and rapid increase in temperature and pressure. Okay, because it causes a great pressure to go down, and because it is heat, combustion has happened, that is why the temperature increases. Now momentum keeps the piston, now as it is going up and down, the momentum keeps the piston moving, and that is how the volume decreases, because it goes up to bottom, top, dead center, and exhaust through exhaust valve, the exhaust gases are thrown out. You can just click a picture of it and write down on your note. Okay guys, moving on to the next. So you can read through this and comment down below if you have any problem. Okay, so this and the fourth this. Okay guys, that's it for today, and thank you so much for staying till here. And if you have understood it, you can tell me in the comment section if I have to improve on any part. I will, because it's a new thing that I'm doing now, and I'm just trying to spread as much knowledge as I have gained throughout this year. I'm still learning, and yeah, and if you have any doubt, please just comment down below. And thank you so much guys for staying till now. Bye.